Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So today we'll be talking about differentiating reducible fractions. So basically, you're differentiating reducible fractions by converting it first to simple fractions before you start differentiating. Because remember in the last videos, I told you that it has to be an index form. Don't worry, we'll talk about this. But before I go forward, don't forget to like, share, and subscribe so that when I post new videos, you'll be the first person to know. So you have to click the notification bell. All right, so let's get started. All right, so before you go into this video, make sure you've reviewed the laws of indices. Make sure you've reviewed the previous video, especially the power laws, and you know how to do it. So it's very important that you do that. So let's assume we have this, and you were told to differentiate, okay, a particular fraction, let's say ax raised to the power L plus bx raised to the power n over cx raised to the power m. Are you seeing it? So where a, b, and c are constants, so you have, they could be constants, and L, m, and n are powers. All right, so in this kind of question, you have something like, let's say 5x squared plus 3x divided by 2x raised to the power 3. And we're told to differentiate this. Or you have something like 5 root x plus 3x raised to the power cube divided by 3x raised to the power 7. And you're told to differentiate this. How do you do it? So remember, like I always say, you have to convert everything to an index form before you start, okay? So don't always forget, regardless of the mechanism of differentiation, you have to convert to an index form first, okay? So you have to review the laws of indices. It's very important so that you can understand this. All right, let's get cracking then. So we have this. So we have 3 rules or 3 steps on how to do this. The first thing you have to do is that you have to rewrite the equation by dividing each of the numerator okay? So each of the numerator terms by the denominator. Okay? Then after you've done that, number 2, you then have to simplify using the laws of indices. Okay? Usually, it's more likely that most times you might end up using the power laws, okay? It's one of the most popular ones. So please go back and have a look and look at the videos on the laws of indices. I gave you several types of the laws of indices. So try as much as possible to go back and review that. Then after you've done that with the laws of indices, the next thing that you have to do is that you then have to differentiate using any of the previous mechanisms. Okay, so I've talked about other mechanisms already. All right, so you can use any of the mechanisms, and any of the mechanisms we've discussed in this series to just solve it. You can use the power rules for the mechanism or power rule with a constant or stuff like that. So any of the mechanisms we've discussed earlier, we can now apply here. All right, so let us, using this now, let us go back to this question here, the general form, and try to apply the rules first before we pick a question. So we have it as ax raised to the power. So we have y is equal to ax raised to the power L plus bx raised to the power n divided by cx raised to the power m, for instance. And we were told to find the y dx. So remember the first step. What is the first step to do? You have to rewrite it by dividing each of the numerator terms by the denominator. All right. So what we are going to do is going to become axl divided by cxm plus, are you seeing it? bxn divided by cxm. So you have to split it. You can't differentiate it when you have a fraction like this. So you have to split it. Now, also, you then have to apply the laws of indices here. So remember in the laws of indices, where you have division, you can subtract. So where we have something like uh, a raised to power m divided by a raised to power n is equal to a raised to power m minus n. We've talked about this in the laws of indices. So we can apply it here. So that means this, I can rewrite this again as a over c times xl divided by xm. Can you see? And I can also write this as b over c multiplied by xn over xm. Are you seeing it? Then it's going to become a over c. Now, I apply the laws of indices now because I know when it's am divided by a raised to power n is m minus n. So this is going to give you x l minus m. And this is going to give us b over c x n minus what? M. Then, after doing this, we then apply the laws. Step 3. We'll now find, so now y is equal to this. Now we can now apply the power rules here to solve this. So we can now differentiate now. So dy over dx will now be equal to, as usual, this is the powers now, okay? You bring down the power and multiply this. So it's going to become a over c multiplied by l minus m, then x, l minus m minus 1. Do you remember? You bring down the power and you now subtract 1. Plus, you do the same thing. You multiply, you bring down the power. So it's b over c multiplied by n minus m. Then we'll have x, n minus m minus 1. And that will be that. Okay? So let's pick an example. So basically, you separate the fractions. And after separating the fractions, you apply the laws of indices. And when you apply the laws of indices, then you differentiate. All right, let's pick an example to make this clearer now. All right? Now, let's say we have y is equal to 5 plus 6x squared divided by 7x cubed. Okay? And you were told to differentiate this. So the first thing, step 1, we have to separate them because you can't have them together. So y will be equal to 5 over 7x cubed plus 6x squared over what? 7x cubed. Okay? Then we then apply the laws of indices now. Okay? So we can now separate this to be 5 over 7 multiplied by 1 over x cubed. Okay? Plus 6 over 7 multiplied by x squared over what? X3. Now, following the laws of indices, I told you in the laws of indices that 1 over a raised to power m is equal to a raised to power minus m. Okay, we talked about this in the laws of indices. So that means I can now say y will be equal to 5 over 7. Now I can apply this law here. It's going to give me x raised to power what? Minus 3. Okay, so we're converting it to index plus. Now this one as well, I'm applying the same division law, where it's a raised to power m divided by a raised to power n is equal to a raised to power m minus what? N. So this is now going to give us 6 over 7 x will become 2 minus 3, and that will give us what? Minus 1. Okay, so you're going to subtract the power. So 2 minus 3 will give you minus 1. Then step 3 now, we then have to then differentiate. So now we can now start differentiating. So you can see, you don't differentiate when it's this in this form. You have to reduce it back to simple fractions. So dy over dx is going to be equal to 5 over 7 times minus 3. The power loss, you multiply this, then it will now become x, then minus 3 minus 1, plus the same thing, 6 over 7 times minus 1, and it's going to become x minus 1 minus 1. So this is now going to give us minus 15 over 7, x minus 4. Are you seeing it? Then minus 6, so because 6 over 7 times minus 1 will give you minus 6 over 7. Or, to make it easier for you, you can put it this way. You can say plus, into brackets, minus 6 over 7. If that will make you happy, and minus 2. So plus times minus will give you minus. So it's going to be minus 15 over 7. X raised to the power minus 4 minus 6 over 7. X raised to the power minus 2. And this is the dy over what? Dx. Okay? So when you're doing this, you have to ensure, all right, that you have to follow the steps. You have to separate it. Then you apply the laws of indices, convert it to index form. Then you what? You differentiate. All right, let's pick one more example, okay? Let's pick one more example. Let's assume we have y is equal to 3 plus 4t plus 5t cubed divided by t squared, all right? And we're told to solve this. So let's go. So the first thing, step 1, we have to separate it. So y will be equal to, and put step 1, so it will be easy for you to understand. So the first step, we need to separate it. So be y will be equal to, or another thing you can do, you can pause the video, try and solve it, and see if you get the same thing that I got, okay? So you can just pause the video and try solving it on your own, then come back and see if you got the same answer that I did. So let's go. So it's going to become separated 3 over what? T squared plus 4t over what? T squared plus 5t cubed over what? T squared. Are you seeing it? Then what is step 2? You then have to simplify using the laws of indices, right? So let's go. Then we can now write this again to be clear. So we can say this is something that's saying y is equal to 3 times 1 over t squared, to make it clear, plus 4 times t over what? T squared. So basically it's the same thing. I'm just trying to separate it so that it'll be easy for you to understand. And same thing as saying 5 multiplied by what? T cubed over what? T squared. So you can see it clearly. Now, the same principle, we're going to apply the laws of indices here. Okay? So we're going to have y. So we have 1 over t squared. So remember the laws of indices. When you have, when it's 1 over a raised to the power m is equal to a raised to the power minus m, right? So that means it will now become y will be equal to 3 multiplied by t raised to the power minus 2. Are you seeing it? Plus division. So remember a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. So please make sure you go back and watch my videos on the laws of indices. So now you can see here, remember that if there is nothing showing here, that means there's a 1 here. So that's going to give you t. 1 minus 2 will give you minus 1 plus 5 multiplied by 3 minus 2, and that will give you what? 1. So it will now be y will be equal to 3t minus 2 plus 4t minus 1 plus 5t. All right. Now the next step, we need to go to step 3 now, which we need to differentiate. So now we have this as now, we have it as y will be equal to 3t minus 2 plus 4t minus 1 plus 5t. So dy over dt, okay? So it's not going to be, it's dt because they're differentiating in respect to t. Dy over dt is going to give us, as usual, the power rule, the power multiplied by the number here. So it'll be 3 multiplied by minus 2, then t minus 2 minus 1, plus, then the same thing, 4 multiplied by minus 1, then t minus 1 minus 1, plus. So remember, in this example here, if there's nothing here, that means there's a 1 here, all right? So it's going to become 5 multiplied by 1, t 1 minus 1. So therefore, dy over dt will be equal to 3 times minus 2 will give you minus 6, t raised to the power minus 3. Then 4 times minus 1 will give you minus 4. Minus 4 times plus will give you minus 4. Then t minus what? 2. Then plus 5t raised to the power what? 0. Now remember, t raised to the power 0 is 1. So that will now give you equal to minus 6t minus 3 minus 4t minus 2 plus what? 5. And that will be the answer for that. So that will be dy over what? dt. All right, and that will be the answer for that. All right, good. So let's go to the next one. All right, so we've solved an example for this. So just go to the worksheet, try to solve loads of questions and try to practice and see if you get the same thing. All right, so I'm going to give you some exercises to try. I want you to try this. So try this question. So we have y is equal to 8 plus 9x plus 10x squared divided by what? X cubed. The next one, we have y will be equal to 3x plus 9x squared divided by 4x. We have next one, we have y is equal to 5x squared plus 7x plus 4 divided by x raised to the power 4. And we have another one, y is equal to 8x cubed minus 3x divided by 4x squared, okay? So in all this case here, I want you to find the y over what? The x. So as usual, you can solve it on your own, put the answer in the comment section so other students can also see and maybe like and see if you're correct or not. And if you're sure you can't solve it, you're still struggling, feel free to put it in the comment section and let me know, or you can send me an email, or if you see me, you can stop me and I can show you how to solve it, okay? All right, so we've done with that. We've solved how to differentiate reducible fractions, okay? Now we're gonna go to the next video, which will be differentiating simple brackets, okay? And our advice for you to make sure you subscribe and click the notification bell. So when I upload the next video on how to differentiate a simple bracket, you'll be the first person to know, all right? So I'll see you in the next video. Don't forget, when you are having this kind of fractions, you have to separate it by dividing each of the numerator by the denominator, apply the laws of indices, and now differentiate using any of the mechanism with what we've talked about. All right, see you soon. I'm going to see you in the next video where we talk about how to differentiate simple brackets, okay? So see you soon.